Alright, Assalamualaikum warahmatullahi wabarakatuh. Good morning and hi. Okay, today our group going to present fluid mechanics assignment, which is the topic pressure in pipe. So, this is our group member. First of all, I would like to introduce myself. My name is RANO AMERZAD bin RAZALI. My method number B0920102334 as first presenter. Next, Nur ATIKA binti ABDUL GHANI as second presenter. ZULHAMIZAN bin ZULKIFLI as third presenter, Muhammad HAKIMI bin AZHAR for the next presenter, and lastly Muhammad Daniel HAIKAL bin Muhammad RAZALI for our last presenter. Okay, now we're going to our introduction. For this assignment, actually we're presenting about fertigation. So what is fertigation? Fertigation is one way of growing vegetable with advantage of minimizing amount of watering. There are two types of pipe configuration may be applicable for the watering process, namely straight line and closed loop. These two configurations will give variance in terms of flow rate as well as the volume of water received by each plant. This situation later will affect the quality of the plant itself. So that is for our introduction. Next, for this assignment, we have objectives that we need to achieve. So, for the first one, to perform experimental and simulation flow exercise in hose pipe. Next, to analyze pressure variance in hose pipe over a specific pipe length with two different configurations. And the last one is report the finding in appropriate approach. Okay, before we start our assignment project, these are experiment equipment that we need to have. First of all, we need a hose pipe with dimension about 20mm of diameter. Next, we need 3mm single connector, then 16mm T connector for connect the hose pipe. After that, measurement tank with capacity about 1 liter of volume, hose clip for grip the PVC hose pipe. Next, stopwatch. And lastly, we need PVC pipe white tape for prevent the leaking on the pipe. So that's all for me. Thank you.
Experiment setup. For the figure 1, first we just connect the hose pipe to the water tap. Then we need to measure the maximum flow rate and velocity from a hose pipe. Then we continue to measure the maximum achievable water check. Then we calculate the maximum pressure in pipe based on Bernoulli equation. For the figure 2a, we set up the hose pipe as shown in the picture. Then we use the single connector to fit 3 holes at equal distance. At the end of the hose pipe, we block the end of the hose pipe in order to stop the water from flowing throughout to the hose pipe. The whole pipe must on the same level. Then open top up to maximum and pressure the flow rate at each hole all in once over the same period. So by this experiment, water can flow by throughout from single connector. From this experiment, we need to calculate the amount of the water in fixed of time that need to calculate the flow rate. For the figure 2b, we set up the hose pipe as shown in picture. We use the T connector to make it a closed loop. The whole pipe must on the same level. Then open top up maximum and measure the flow rate at each hole all in once over the same period. So by this experiment, the water just circling around the pipe and throughout at single connector. We need to calculate the amount of the water in a fixed time that need to calculate the flow rate. Then we record the data.
About the results in experiment 1. The achievable height of water record is 1.07 meter. Volume of water collected is 13.55 liter or 13550 millimeter. Result in experiment 1A. Water collected that we got from beaker A is 170 mm, for beaker B is 160 mm, for beaker C is 170 mm. The time taken is 30 seconds. Total water collected from 3% is 500 mm. Result for experiment 1B. The water collected that we got from beaker A is 140 mm, for beaker B 150 mm, for beaker C 160 mm. The time taken is 30 seconds. Total water collected from 3% is 450 mm. Calculation in experiment 1. The diameter is 0.020 meter. Volume of water is 0.0136 meter cube. time taken is 30 seconds. Achievable water jet is 1.07 meter. The ATM is 1011325 Pascal. For area, the formula that we use is pi d squared over 4. The value that we got is 3.141 times 10 power of negative 4 m square. The flow rate, the formula that we use is V over T. The value that we got is 4.5333 times 10 power of negative 4 m cubed over second. For velocity, the formula that we use is Q over A. The value that we got is 1.443 meters per second. To find P1, we use the formula P1 per rho g plus V1 per 2g equal to P2 per rho g plus Z2. The value that we got for P1 is 110.7809 kilopascal. Calculation for experiment 1A, the diameter is 0.003 meter, the time taken is 30 seconds, volume measurement cup A is 0.00017 m cube, volume measurement cup B is 0.00016 m cube, volume measurement cup C is 0.00017 m cube. The area that we got is 7.069 times 10 power of negative 6 m squared. Flow rate that we got for cup A is 5.667 times 10 power of negative 6 m squared m cube over second. The velocity for cup A is 0.802 meter per second. Flow rate for cup C is 5.333 times 10 power of negative 6 m cube over second. The velocity for cup B is 0.754 meter per second. Flow rate for cup C is 5.667 times 10 power of negative 6 m cube over second. The velocity for cup C is 0.802 meter per second. Calculation for experiment 1B. The diameter is 0.003 meter. The time taken is 30 seconds. Volume measurement cup A is 0.00014 m cube. Volume measurement cup B is 0.00015 m cube. Volume measurement cup C is 0.00016 m cube. The area that we got is 7.069 times 10 power of negative 6 m cube. The flow rate for cup A is 4.667 times 10 power of negative 6. The velocity for cup A is 0.660 meter per second. Flow rate for cup C is 5 times 10 power of negative 6 m cube over second. The velocity for cup B is 0.707 meter per second. The flow rate for cup C is 5.333 times 10 power of negative 6. And the velocity for cup C is 0.754 meter per second.
Okay, we continue the slide presentation. So I will explain about the axis simulation. First about the okay. Alright. First about the first part with L part. For this part, we use dimension for the outlet in let until the bottom is 150 mm and this part until the outlet with is 300 mm. For the mesh part, for the mixing, the first the sizing that we choose 3 face at the boundary with this part at the corner and the outlet. Alright, now for the data of open the simulation part. Alright, so we can see so we can see the material we use water liquid because we use the water in the experiment. And for the material for this pipe we use aluminium because it does not have any rubber material. Alright, method. So and for the method we choose the green charcoal base and the pressure is second order, moment is second order unwind, turbulent kinetic energy and dispersion rate is second order wind. So here you can see the result we got from this pipe, which is for pressure. We choose inlet and outlet and click compute. The Thus we get for the pressure is 78655.56 in Pascal. For the velocity, we choose the inlet outlet selection and compute. The average of the phase value is 2.547897 amperes. This is for L pipe, and you can see for result you clear the result. So, and you can see this control the pipe L pipe and velocity speed apply. Alright. As you can see at this corner, that height velocity we can be obtained from the other pipe is same with pressure. As you can see here, yes, the pressure can see at the corner is height. It is of done for the L pipe. Okay, we continue for the another part. Open the Y connector. So click mesh. So this is a mesh selection. This is a geometry. The dimension for this connector is from here, which from here until the center is we set to 30 mm, and for the diameter for the outlet you can see the diameter this outlet, and the inlet same with 9 mm. As you can see the mesh part, there are 3 phase for the boundary, which this is outlet and inlet. Actually it have 2 outlet and 1 inlet. It's outlet inlet. Okay, for the data part, so go to the solution, click solution, and this is for the machine outlet selection. For material same with the L pipe, which is water liquid, and aluminium because it still does not have a rubber pipe. We use aluminium because it is effect from the data for the experiment. For the method, it is the same. We choose a grain cross curve base, pressure for second order, momentum second order upwind, turbulent kinetic energy, and distribution rate is second order upline. And so we go to report surface integral. Alright, for this here, for here we can see the pressure for inlet and outlet session, which is 0.380595. I don't know why it is so low pressure. And for the velocity is inlet and outlet is 1.973886 meter per second for this Y connector. Okay, lastly click result. Okay, for the Y pipe contour we can get the pressure. As you can see here, we got a higher pressure at the selection and for velocity we got the highest velocity for the inlet selection and the lowest velocity in outlet selection. And as you can see, this is a Y pipe.
4. Okay, now I will explain about the discussion for this assignment. Based from the experiment, we're able to see that the experiment 1 able to achieve the highest flow rate and the highest velocity among the experiment 1A and 1B. So based on the table, experiment 1 has a bigger area compared to experiment 1A and 1B. For the experiment 1 also, the flow rate is the highest among experiment 1A and experiment 1B, which is 4.5333 times 10 negative the power of negative 4 meter cube. Next, the velocity of experiment 1 is also the highest among experiment 1A and experiment 1B, which is 1.443 meter per second. Next, the weakness from the experiment that we conduct is the pressure of water is not stable because of the different type of water tap source. Due to the location of the water tap, we are not able to use the same water tap. Other than that, the temperature of surrounding, which is too hot, will affect the pressure of water. During the experiment, the weather condition was a little bit hot, and lastly, there were leaking around the nozzle, which will affect the experiment result. Even though we already covered up the surrounding of the water nozzle on the rubber pipe, there are still a little leaking occur on the nozzle. To overcome the weakness during the experiment, we need to use the same source of water tap for all of the experiment to get a better reading of water pressure. Next, we also can do the experiment during an overcast weather to get a standard temperature of surroundings so that the pressure that we obtain from the water is similar to the theoretical value. Other than that, we need to make sure not to cause any major damage on the rubber pipe during puncture the hole for the water nozzle, as it will cause leaking and affect the water pressure. And lastly, we can improve the quality of data by taking a multiple reading of volume water. As a conclusion, we acknowledge that the flow rate and velocity of water for experiment 1A and 1B were similar close. Next, we're able to get the pressure of water using the Bernoulli equation from the experiment 1, which is 110.7809 kilopascal. We also able to acknowledge that when the area is increased, the flow rate of water will also increase. A higher flow rate of water will also lead to higher velocity of water. And lastly, even there were weakness during the experiment, we're able to conduct the experiment successfully and we're able to achieve the objective of this experiment. That's all from me. Thank you.